Hey there, cats and kittens. Great to be back from spring break. I had a great time myself. We had a lot of family time, family dinners, and family game nights. So it was a family oriented week. A great time for us. If you have any good stories about what you did over spring break, shoot me an email and I'll share them with the class. I figure we could start up with a semester review to get you back on track after the long break. We'll be covering chapters 22 and 31, but this week we're just going to hold off and cover down on electricity and magnetism. Okay? First off, electricity. Electricity is moving electrons. Very simple, very straightforward. Electrons shooting in a straight line, always going in a straight line. We have two different kinds of electricity. We got static electricity. I wish I could break out the balloons for you here, but I don't think it would have the same impact over the video. That's potential. We have our current, that actual energy that's moving from one place to another, the kinetic energy, the energy of movement. Since electrons are energy, and they are moving, we know that all moving energy must travel in a wave. So our waves have three variables. The frequency, how frequently is this wave hitting you? The frequency. The amplitude, how tall it is, how loud it is. And then we have the wavelength. The length from one part of the wave to the same part of the next wave. The length of the wave is the wavelength. So all of these different energies that we find, all these different radio signals, TV signals, satellite signals, light, is all just variations of these same three variables. When we're dealing with our materials with electricity, we have materials that are conductors, whether they're man-made or natural. Conductors move those electrons down the line, allow them to move along the surface of that material. Your insulator does not. It stops it. It's designed to prevent things from moving through. A semiconductor, it allows some things through. Same with resistors. They allow some things through. So the semiconductor is a control on the amplitude of the wave, how much energy. Your polarized sunglasses, the amount of energy, the height of the wave. It only allows those lower size waves, those amplitudes of a smaller size to get through there, so it doesn't damage your eyes. UVA versus UVB. It controls the amount of energy that is in each wave that goes through. On the other side is the resistors. It controls the frequency. How many of those waves are hitting you? Think of a faucet. It doesn't care what kind of water comes out. It could be brown water, rusty water, dirty water. Any kind of water can come through that faucet, but only so much is coming through at a time. The frequency, how many of these waves are hitting you at a given time. It'll slow it down. It'll pull it back and limit the amount of water that hits you at a time. Next topic we're going into is magnetism. Very related to electricity. It also involves the moving of electrons. But in the case of magnetism, these electrons do their spinning thing. They spin around and spin around. Every electron in the universe spins. No exceptions. It's just a thing. So every electron's spinning. How come everything isn't a magnet? Well, we start going back down to our atomic structures. We have our S shells, that's two. If those electrons spin, nobody can feel that. Same thing with the P shells. We got those three circles. They're not as strong either. There aren't enough of them to have an impact. When we get into our D shells, our metals, we start having 5 shells, 10 electrons. And if all of those are spinning in the same direction, all of those have the same magnetic field, then we start to feel that. That's why we first have metals that become magnets. Iron, copper, all of these great metals. They're conductors. They're carrying these magnetic fields around, allowing them to spin, allowing them all to spin at the same time, in the same direction. So they have a composite feel, and we can feel that magnetic field. Our Earth has a huge chunk of iron at its core, a big metal center that creates a magnetic field all around the Earth. Flows from the North Pole, which happens to be negative, to the South Pole, which happens to be positive. So those electrons, they're shooting around trying to create that balance. As we're going around this Earth, it creates that force field around the planet that allows us to be safe from all the cosmic rays coming from the sun, from metal asteroids coming in to blow up the Earth. It's a great protection. If you notice Mars doesn't have an atmosphere. Mars doesn't have life. Mars doesn't have a magnetic field. That's one of the main reasons it keeps us safe from space attacks. Now we move into that smarter than Einstein part, if you remember back there. These electrons, this electric current, our electricity, bonding the two of these ideas together, these electrons moving in this wave, because every moving energy source has to travel in waves. It's just a thing. So the energy source for these waves is this magnetism, these spinning magnetic fields, just like an engine, driving these things along, forcing these electrons to continue to move down in waves. So we have this energy source, this power source that's pushing these electrons forward. And as far as these electrons know, they're part of a gear. The serpentine belt in an engine, as the engine spins the energy source around, drives the power to the axles and the wheels. Finally, I'd like to talk about a few mechanisms that we use to generate electricity. Our technological society is based on electricity. We have to be able to control it. We have to be able to use it to make our society function. We always start with this induction coil. The whole basis of our electricity is based on this induction coil. Long time ago, about 1634, they found out that if you take a magnet, this metal where all the electrons are spinning in the same direction, you take this magnet and you wrap a conductive cord, a conductive current, a conductive wire around this magnet, we see these spinning magnets, and it causes those electrons to flow down the wire and flow them out here, and we create an electric current. And we cause things to light up, and we start to control the electricity that we need. Unfortunately, it doesn't do that much. It doesn't produce enough electricity for us. We don't get the amount of power we need to run our cities. So we also found out that instead of wrapping the wire around the magnet, we could wrap the magnet inside the wire, or spin that magnet inside the wire. So every time this magnet goes around, it's like another wrap of this coil around the induction magnet. Another wrap that generates more and more power to force those electrons down the wire. So this thing spins thousands of times a second. There's no way we could get thousands of those coils around this magnet, so we're generating a massive amount of electricity compared to the induction coil. Your modern generator generates about 25,000 megawatts. That's a whole lot of electricity. So this spinning magnet spins and spins and spins as fast as they can make it go, and it generates these electricity come around, and it lights our light bulbs, and it runs our cities. But we don't always have to be plugged into the wall, because these electrons are coming out through this socket in the wall into our light bulbs. Sometimes we just need a battery. When I unplug my laptop, it's not connected to the generator. So I have to have a way of storing this electricity, a way I can keep this electricity for use when I'm not always plugged in. We take a magnet, a battery with an insulator in the middle. It's got negative charges, electrons all grouped together in one spot. And then it has positive charges all grouped together in another spot. This insulator doesn't allow those two to mix. As we all know, Nature does not like an unbalanced situation. It has to be balanced. Nature always, always, always needs to be balanced. So it finds a way to take these negative charges, flow them around this cord, like the light bulb, and connect through into the other half of the battery, so that all these negative charges can find their partner, positive charges, and balance themselves out. When all of these negative charges have made their way around to the positive charges, then that battery is dead. And now we can force those electrons back across and recharge the battery again. We're learning how to generate electricity, make large amounts of electricity, and store that electricity for use in our societies. We're really coming a long way. Every generator, every power source, every source of electricity in the world comes from this generator. It's generated by that, stored once it's been made, but all of it comes back to this. Maybe you guys can come up with a better system, something that's more effective and more efficient. Let me know. I'd be great. I'd love to hear about it. See if you can come up with a new idea. Hey, if you can solve the world's energy crisis, that's got to be worth at least 10 extra credit points. Okay, I'll see you guys next time.